So Pluto, right, that little dwarf planet. Way out there that used to be a main planet, well, it's back in the news. Because some big-name scientists like Neil deGrasse Tyson and MIT Okaku are saying it might actually crash into Neptune. How could that even happen, and what if it did? Would it be a big deal? Here on Earth, scientists are trying to figure out if this is just some weird space thing or something bigger. Pluto's always been a bit of an oddball. It got demoted from planet partly because its orbit is so strange, and now people are saying it's getting too close to Neptune. Tyson and Kaku are even warning about a possible crash. Seriously, so how's this even a possibility? Pluto's orbit is just weird. It takes 248 years to go around the Sun. Just once since we found it in 1930. It hasn't even made a full circle also, so its path isn't a perfect circle like the other planets. It's more of an oval on a slant. And here's the crazy part, Pluto's orbit actually crosses Neptune's for about 20 years of its orbit. Pluto is even closer to the Sun than Neptune, so why haven't they smashed into each other yet? Well, it's because gravity from other planets affects them. When Pluto was first spotted, astronomers were scratching their heads about its weird orbit. It's tilted and oval-shaped unlike the other planets, and the fact that it crosses Neptune's orbit just made things even weirder. The fact that Pluto is still out there without hitting Neptune shows just how complicated things are in space. You've got Pluto, Neptune, and the Sun all pulling on each other. It's hard to know where they'll end up. Scientists use terms like oscillation to explain it. Basically, when Pluto crosses Neptune's path, it's always far enough away to avoid a crash. Plus, Pluto moves up and down a lot in its orbit, so when it's closest to Neptune, it's usually higher up, which keeps them from colliding. If you add the way the Sun's gravity affects them, it turns out that even if Pluto's path looks strange, these oscillations help keep it steady. All this keeps Pluto from crashing into Neptune or getting lost in space. Back in the 80s, some computer tests showed that Pluto's orbit is a bit unpredictable. Tiny changes could cause big differences over time. Luckily, Pluto's orbit is steady for billions of years. Scientists use computers to see how the big planets Neptune, Jupiter, and Saturn affect Pluto's path during orbit. It's like these planets are all working together to protect Pluto. Jupiter's gravity is strong enough to keep Pluto on track. Without that, our solar system would be chaotic. Planets could crash into each other or get thrown out of the system. That's why understanding Pluto's orbit is so important, especially now that people are talking about it hitting Neptune. Pluto's story shows how even unstable seeming orbits can find balance because of gravity. It also reminds us to keep watching and studying these things so we can learn more about our place in the cosmos. Space is wild, and Pluto's orbit proves it. Even though it can change a lot based on small things, it stays stable for billions of years. Predicting space stuff, especially with crazy orbits like Pluto's, is hard. These systems are so unpredictable that it's tough to say what will happen in the long run. Computer models help, but they're not perfect. Small mistakes can lead to big differences. The wild nature of orbits like Pluto reminds us that the universe is always changing. Even though we've learned a lot about space, Pluto shows us that there's still so much we don't know. So why are folks like Tyson suddenly worried about Pluto hitting Neptune? Well, Tyson has been saying that the more we learn about space, the more questions we have. Kaku thinks we need to keep watching space really closely because things can be pretty unpredictable. They both agree that space is full of surprises and that we need to keep exploring and learning. Even though most scientists think Pluto and Neptune are safe for now, we still need to keep an eye on them to see what happens in the future. Better telescope and computer models will help scientists make better Predictions Tyson and Kaku remind us that we need to keep exploring and be ready to change our minds as we learn more. The idea of Pluto hitting Neptune shows us how complex and exciting our solar system is. It reminds us that there's still a lot to learn about space, and we need to keep exploring to find out what's out there. They're suggesting that Pluto might actually be on a collision course with Neptune. That's kind of a crazy thought, right? So how could that even happen, and what would it even look like if those two actually bumped into each other? Is this just a weird random thing happening in space, or is there something bigger going on here? Let's get into it. Even though Pluto got demoted to dwarf planet status mostly because it has such a funky orbit, but still it's always been a source of questions for folks who study space. Now the latest thing is that some scientists are saying Pluto is getting way too close to Neptune, and it's none other than Tyson and Kaku that are making these statements about a possible impact. If they crashed, it could cause problems even here on Earth. Maybe the first thing you're probably thinking is, how is that even possible? Pluto's orbit isn't like the other planets. It takes Pluto a crazy 248 years to go all the way around the Sun. I mean, they found it in 1930, and it still hasn't even made one full lap yet. And it gets even stranger because Pluto's route isn't a nice round circle like most of the other planets. It sort of reminds me of stretched out oval. On top of that, it's tilted compared to the other planets, kind of like it's leaning to one side. This tilt and oval shape make its orbit super wacky. One of the craziest things is that Pluto's orbit actually crosses Neptune's, so it gets closer to the Sun than Neptune for about 20 years of its orbit. This begs the question, why aren't they crashed into each other already? The answer has a lot to do with the pull of the other planets and the gravity from the Sun. When it was first found, people couldn't figure out what Pluto was doing out there. Unlike the paths of the main planets, it looked tilted and not very rounded. It got even weirder when they discovered that Pluto and Neptune actually cross each other's courses. The fact that Pluto was still floating along is all down to the complex way space works. The motion shows that Neptune and the Sun interact to affect Pluto's course, and the answer as to why things are steady is the fact that when Pluto is crossing Neptune's orbit, it's always super far away from Neptune itself. Think of it as they are at least 90 degrees apart. This means they never get close enough to bump. Also, Pluto moves up and down when it's nearest to Neptune. It's either way above Neptune's PTH or way below. This is something called VZK oscillation, and that's how they move relative to the Sun. This helps folks figure out why Pluto's path is so unusual. It makes sure Pluto moves smoothly instead of all over the place. This keeps Pluto's orbit steady and makes sure it doesn't just go flying away somewhere. This makes our whole solar system more predictable. If that wasn't true, Pluto could get thrown off course and crash into something. Computer tests from way back in the 80s showed that Pluto's orbit can change a fair bit with only small changes to how scientists were thinking about it. On top of this, Neptune and Pluto fall into a 3-to-2 orbital resonance, where for every 3 times Neptune goes around the Sun, Pluto goes twice. Jupiter and Saturn, the other big fellas, also work to help Pluto stay in its lane. Due to this strange coupling, it's even more important for keeping things steady throughout the solar system. If things like Pluto weren't able to orbit right, the whole system could just go totally haywire. What's the bottom line? Well, even orbits that seem unstable can end up doing okay and reach equilibrium through this crazy dance of gravity. These computer models are handy for figuring out what's up. They use math to show how Pluto and stuff in space affect each other. Very tiny changes in these models can make a big difference in where Pluto ends up. It's super tough to predict this stuff with Pluto's chaotic orbit. These systems are so all over the place that it's hard to know what's going to happen long term. Even though these simulations help our understanding, they also show how tough it is to guess what is going to happen. These models rely on knowing the right facts. Any small mistake can mean big messes down the road, even with the big planets trying to keep something like this from going down. Why are Tyson and Kaku only mentioning this crash now? Tyson is good at explaining science in plain terms, and he's got thoughts about Pluto. He thinks that the more space folks learn, the more it makes sense to call Pluto a dwarf planet. You know, he sees how hard it can be to know where something like Pluto is going to be way into the future. He's got to focus on continuing to learn. Kaku is always looking ahead. He thinks we need to keep modeling and keep watching to see any possible problems up ahead. He sees any action between planets, etc., as key to knowing how space runs on all levels. Tyson and Kaku pretty much both agree that space is just getting harder to know, and our models must become better as our tech gets stronger. So what's the conclusion? Well, there's a scientific idea that things between Pluto and Neptune work for right now, but that folks need to keep watching to look for any long-term worries. Even though Pluto got demoted because its orbit is weird, it still makes astronomers wonder. The latest thing is that Tyson and Kaku are saying Pluto's path is getting way too close to Neptune's, and a crash could even mess things up here on Earth. First thought, how is that even possible? Pluto's orbit is not like other planets. It takes a crazy 248 years to go around the Sun. Once it was only found in 1930, and it hasn't even made a full circle yet. It gets weirder. Pluto's path is in a nice circle. It's more oval-shaped and tilted. This makes its orbit super strange. One of the craziest things, Pluto's orbit crosses Neptune's for about 20 years. Pluto is closer to the Sun than Neptune, so why haven't they smashed into each other already? It's because other planets' gravity affects them. When Pluto was first found, people couldn't figure out what it was doing out there. Its path looks tilted and not very circular. Plus, Pluto and Neptune's paths meet. The fact that Pluto is still fine shows how complicated space is. The gravity of Neptune and the Sun affects where Pluto goes. Physicists say that when Pluto crosses Neptune's orbit, it's always far away from Neptune itself, at least 90 degrees, so they never get close enough to hit each other. Pluto also moves up and down, so when it's nearest to Neptune, it's either far above or below Neptune's path. This is why Pluto's path is so unusual. It makes Pluto move smoothly instead of all over the place. All this stuff keeps Pluto's orbit steady so it doesn't hit Neptune or fly off somewhere. Without it, the solar system would be chaotic. Pluto could get thrown off course and crash into stuff. Computer tests from the 80s showed that Pluto's orbit can change a lot with only minor changes to where scientists thought it would be. Also, Neptune and Pluto have a 3:2 orbital resonance. For every 3 times Neptune orbits the Sun, Pluto orbits twice. Jupiter and Saturn help keep Pluto's orbit as it should be too. Without this, the whole system would be chaotic, so even orbits that seem unstable can work out and reach a balance through gravity. Computer models are helpful for figuring out what's going on. They show how Pluto and other things in space affect each other. Even minor changes can make a huge difference in where Pluto ends up being. Predicting events with Pluto's crazy orbit is super tough. These systems are so tricky that it's hard to know what's going to happen long term, though simulations are great. They show how hard it is to guess what will occur. These models need the right details at the start. Any small mistake can lead to big problems later. Even with the giant planets trying to keep things from happening. Why are Tyson and Kaku bringing up a possible collision now? Tyson wants to make science easy to understand. He thinks that calling Pluto a dwarf planet makes sense. As we learn more about space, he sees how hard it can be to tell where Pluto will go, so he focuses on learning. Kaku always looks to the future, saying we need to keep modeling and watching to see any potential issues. He thinks figuring out how things interact is vital to understanding how space works. Tyson and Kaku basically think that space is complex and our models have to keep getting better as technology does, even though most scientists think Pluto and Neptune's orbits are stable right now. It's important to keep watching and working on any long-term risks.